From the heartland of America and the gateway to the West, good morning, good evening, wherever you may be across the nation, around the world. I'm George Norrie, and welcome to the world's most listened to late-night talk show, Coast to Coast AM. Dr. Walter Wagner is our guest this hour. He graduated from Berkeley with a minor in physics, a major in biology. Later, he discovered a particle in a balloon-borne cosmic ray detector, initially identified as a magnetic monopole. Though its identity now remains uncertain, it is definitely not within the standard repertoire of known particles. He's an expert in physics. He's an expert on what's going on at CERN, and he's our guest this hour. Walter, how are you?
Good evening, George. I'm doing great.
Good. Now CERN, they're going to turn that on soon, aren't they?
Well, it's already in the cool-down stage. It's not just a single switch that you do. It's a very complex process. And the large 27-kilometer diameter ring where the particles will be accelerated has to be operated at a temperature of about 2 degrees Kelvin. That's the temperature of outer space. And that takes a long process of cool down, starting off initially with liquid nitrogen to cool it down to liquid nitrogen temperatures, and later with liquid helium to cool it down to liquid helium temperatures. And they're in that process. It'll be about another month before it's reached operational temperature. And then they have to inject beam into the ring, and that takes a couple of months to get that done if everything goes according to the design.
Now, Walter, this particle accelerator is built underground, correct?
Yes, it is.
How far down is it?
Oh, it varies, of course, from the surface. It's on the order of 70 meters or so. It's not real deep. I believe it's in some places 100 meters. It's underground because when you are running these high-speed protons or other particles through this ring, they produce what's called synchrotron radiation. And that is a very high-energy photon, very penetrating, and it goes through several feet of dirt. And so put it under 100 feet of dirt, and you're safe.
So that's why they went down that way.
That's why, right. It makes it a lot easier. Also, it out of sight, out of mind. They don't have people thinking about it.
Now, are we correct, those of us who think that something could happen if this isn't done right? Or are we way off base?
We're exactly correct, George, and that's the unfortunate part about this. There have been reviews that have been done that have confirmed the things that I have been saying. Reviews done by the people at CERN themselves, and so it has given them cause for great concern. And in addition, the great promotion of Hawking radiation as being the fail-safe that would save us is also admitted that it's a 50-50 chance of whether it would work or not. So we're looking at something that has the potential to be very disastrous without any kind of a safety net that we can use to prevent anything bad from happening.
Okay, now tell us, Walter, what's the downside here then? I mean, what could go wrong?
Well, probably the easiest one for people to understand is the potential for creating a small black hole. There are, under normal theories, these things would not be created because there's not enough mass involved in when these two particles collide together. You end up with the mass of several thousand atoms squeezed into a very small volume. And under most theories, that's not enough to make a black hole. But under some theories involving extra dimensions of space and time that we don't normally see in our three-dimensional space, one-time dimension in which we walk around in, if there are additional dimensions, it's possible that it would allow for the creation of a miniature black hole or micro black hole. And there are some theorists who have predicted that this could be the case, and that the energies, or the energy density, I should say, of the Large Hadron Collider might be able to create such a creature. And if that were the case, it could potentially grow larger and eventually, over the course of decades to millennia, devour the Earth.
Literally suck the planet right in.
Well, yes, it would not occur instantaneously because it would start off so small that it would have difficulty interacting with the atoms with the nuclei of the atoms of the Earth initially. But eventually, as it slowly did, every now and then it would interact and suck in a nucleus. Over time, it would get larger, and that process would accelerate. And so eventually it would be able to do it at a very rapid rate. And how long that would take, no one knows. There's estimates. One theorist in Germany, Otto Rissler, has estimated it could be as short as 5 years. I've seen other people say it could be as long as 1 billion years, and everything in between. We really have no way of knowing.
What a bizarre story. Okay, if for some reason let me ask you this. Is that only in the event something technically goes wrong with their experiments, or by the mere fact that they get it running in 3 to 4 months, that it will be created automatically? It's going to happen regardless.
Well, it would happen automatically. Yes, it's not like if something goes wrong. They're trying to create new matter, new forms of matter that have never been seen before on Earth. And there are several different theories as to what kinds of things can be created. And some of the theories are that you could create a micro black hole. There's another particle called a strangelet that some theories predict might be able to be created as well. And it would have a similar kind of disastrous consequence, but exactly the opposite, actually. It would end up in a runaway fusion reaction, accreting atoms into itself and growing larger, but releasing fusion energy, and eventually would heat the Earth up to where the Earth exploded. Instead of imploding like a black hole, it would explode like a supernova.
Initially, if this happens, where would it be? Would it be centered around CERN in Switzerland? Is that where, let's say, this little mini black hole might be?
No. It would, if it were to make one, most of them would be at very high speed relative to Earth, nowhere near the speed of light, but still several 100,000 miles per hour. But there would be a few of them that would be at below the escape velocity for Earth, which most people know is 25,000 miles per hour, to break away from Earth's gravitational pull completely, so you get to leave the Earth and are no longer a satellite around our planet. But if there are some of these black holes are produced with speeds below that, they would become a satellite, if you will, around planet Earth and orbit around and through our planet.
How weird!
It would spend perhaps an hour traveling through the planet, and then several hours up into space, and then back down for an hour through the planet, and several hours up through space, and just keep on in an orbit like that. Every time it sucked up an atom and grew a little bit larger, its orbit would shrink a little bit, grow a little bit smaller. Eventually, its orbit would be entirely within the Earth, and eventually orbit would start shrinking small enough that it would sink towards the center of the Earth.
Oh, maybe it's not nice to play around with Mother Nature, Dr. Wagner, huh?
Well, it depends on how you're playing around with it. There's nothing wrong with doing passive experiments or observing what Mother Nature puts out there. We have a lot of satellites out there observing nature, and there's nothing wrong with that. We have telescopes observing nature. There are a lot of things we have done which we have very good control over, and there's nothing wrong with doing those kinds of works. Some people have said, well, if we never experimented with nature, we'd never acquired fire, and that's true. So there are some experimentations that's perfectly acceptable. But once you have identified some problems, you have to be able to prove that they're not going to happen. It'd be the same, no different than if you built a dam over an earthquake fault, and later on you found out there was an